Hi, I'm Nathaniel Poland, and welcome to my portfolio showcase. In this video, I'd like to go over a few of the projects that I've produced over my learning journey the past few years. I'm a new entry into the data science and programming fields, formerly the lead baker and mentor at a small nonprofit in Toronto. And in that role, was deeply involved in the end-to-end operations of the small business. So more than just my technical skills today, I'd like to showcase that I understand the ins and outs of running a business, from the bottom line to building strong teams, and hopefully bringing it all together in a efficient workflow. So without further ado, let's get started. So the first project I'd like to cover is this Streamlit dashboard that I put together using some stock functions that I originally wrote in fall of 2021. The business solution here is to use clean data to drive your decisions. So sourcing clean data. At the time, I had very little experience working with data warehouses or even cloud-based data storage providers, and so using web APIs was the first step for me towards towards understanding the end-to-end data lifecycle and the concepts of extract, transform, and load. So in this project, I abstracted some data requests from the API into functions and was able to pass parameters, very basic stuff. Since then, and more recently, I've turned these functions into Streamlit Dashboard, which I'll show you in a minute. And and yeah, so working with. So here we are. This is the dashboard. Um, as you can see, I've made it. Streamlit makes it so easy to make things interactive here. We can set date ranges. We can change the ticker. Um, we can actually these calculations for the moving averages. We can change them as well. Uh, Short moving average here also affects the Bollinger Bands, which probably isn't the desired behavior, but it's a simple fix if somebody who knows finance would want to tell me more. We can add them in, but it makes it a little bit cluttered. We can go back to the 20-day moving average and switch this up to be just the 2020 sort of run and see what it looks like. So the code's over here. It's just this for Streamlit, and everything is abstracted in the back end with these stock functions that I wrote or have recently updated. Um, Plot the mean reversal. Uh, Find gold is to find the mean reversals. Add Bollinger Bands. Add moving averages, and then we can, the wrapper around the API is very simple here, but there's a lot more depth to the Y Finance API, and depending on your use case and application, just go in and find the data from the source. So the second project is this Python quiz script. Uh, the business solution that I'm putting forward here is about mentorship, um, retraining the staff, and the acknowledgement of sort of the bus factor, where if one person is the only person who can fix something, uh, it puts a pressure and a strain on the organization if that person were to, for example, leave their job. So the technical skills I want to put forward here are about Python, um, class getters and setters using properties to calculate values on the fly within your application, as well as the concept of data verification. So more recently, I did my own database setup, my own API setup using SQL Alchemy and Fast API. But in this application, I wanted to control the random values that I was generating and have them be within certain parameters, because when things are random, it can get a little bit out of hand. So um, in the end, there was a lot of code iteration and debugging and testing to make sure that everything was how I wanted it to be, how the user experience was, um, could be fine tuned in the ways that I wanted it to be. So let's take a look. You can try it yourself. So here we are in the menu of the Python Quizbot. There's 6 different options here in the menu. Uh, Most of them give you points based on your score, and we'll calculate your score. That's using properties and setters. And so you can see, if we look here, there's a dictionary. This one's a float. This one's an integer. This one is a string. If we go back to the menu and guess the length, then we're going to get data containers, for example, tuples, lists, dictionaries, and sets. This is of length 3. The dictionary now is of length 3. The tuple is of length 3. It's of 2, 1, 2, 1. If you get to a dictionary here, it's kind of a trick. So 1, 2, 3, 4 here. Guessing the index lets you index into either tuples or dictionaries here. So -8 is going to be under the key 13.4. Immutable type has to be the key of a dictionary, obviously. And the index of as, you can see it's both a key and of a value here. So we're looking for -26. You could also index into strings. So for J, it's going to be index spot 0. H, it's going to be index spot 1 and index spot 0. And again, those types are randomly selected. So the type methods multiple choice lets you pick either string, list, or dictionary and associate a method definition with the method's name. So if we pick string, pass an iterable to be joined together using the calling string as a separator. For example, it's almost the same as the collapse function in R. So for us, it's going to be join. Okay, we got the same question twice. But the lowest index, in the string for the given substring is going to be D here. And if we get one wrong, for example, this one's going to be strip. But if we put it in join, it will tell us that the correct answer was strip. So the guess the type multiple choice gives you a list of 4 values. In this case, a tuple and 3 bools. So if we look into the multiple choice menu, it's going to be option B. And here we have a float, bool, tuple, bool. So it has to be B. And when we exit out of the full menu, where did I get 3 wrong? Good Lord. Gives you your percentage, how you did. And that's basically it. The third project I'd like to demonstrate is this dynamic programming data structures and algorithms notebook, which was based off of a video from YouTube from freecodecamp.com. The business problem that I see algorithms solving and big O notation solving is the speed and the cost of production, and as well as the timeliness of your ability to deliver the product, availability in web pages, in machine learning models, everything like that. So big O notation is one of the major technical skills here, the concepts. And in terms of implementation details, the video was written in JavaScript. I translated it over to Python. I think I started this notebook in 2020 in the spring before the bootcamp, and I came back to it and got some practice with recursion. I like tabulation a lot, and learned some interesting things about Python classes, the default arguments, and constructors, which I might go into in a minute. And in that study and sort of struggling with Jupyter notebooks and Python environments, I was introduced to the concept of caching, and it was definitely my first experience wrapping software around my own kind of API. So the API functions, the web API functions from the stocks module was similar, but taking an existing piece of code and suiting it to your needs was the precursor for my ability to write that SQL wrapper for StackAdapt. Okay, so one interesting thing that I learned doing these algorithm sort of exercises was about the default arguments that are passed to a function, and the use of a single constructor basically in the function definition, as opposed to passing it a new dict constructor as a memo object to each of the functions independently. So if you look here, what I'm doing is assigning this default dictionary constructor as a memoization object, And what I'm hoping is that for each recursive call, we will store the value when we're trying to sum up to this value m based on the integers in n, this list, that if we've already reached a certain value in our recursive tree, that we can skip and that tree has been fleshed out, then we don't need to calculate that value again. It's already been done for us. And so I ended up having to enter in this dictionary constructor as the memo object in each one of my calls. And I said, oh, of course I can make this easier. And so I tried to make a default argument for it. But I ran into an issue, which is that inside the function definition is where this singular dictionary is kept. So if I run the CanSum function once, 1, 2, 3, 4, 5, it returns true correctly. Those values are now stored under this assumed value m in the function definition. So if I call it again on CanSum 11 using the integers 4, 8, and 14, can I sum any of these numbers with replacement to create 11? It returns true, which is inaccurate. So if I do pass the dictionary to each one of the functions, then it does return the correct values for each one because it's creating a new dictionary as a default argument. I went looking for a caching option for this. I tried property decorator, and in the end, it wasn't really necessary. It's just one extra argument that you have to pass, and I mean, you could create your own memo object in a separate place as well. But yeah, that concludes this portfolio showcase. I'll be recording some new videos regarding my latest certifications with DBT, Apache Airflow, and Snowflake, as well as maybe a deep dive into my most recent project, which uses Docker Compose to put together a multi-container application running a database, an item potency sort of bespoke Python class, and a Streamlit front end. So that is my most recent exposure to data engineering concepts. And I hope to see you soon.